Now we will see some chemical properties of hydrogen. We know that all chemical properties depends on bonding only, that is chemical bond between atoms and molecules. Okay. We know that hydrogen bond dissociation energy is highest among any single bond. This is because single hydrogen atom is very unstable. Single hydrogen atom have only one electron is in outermost shell, and its octet is not complete. So it will lose an electron or gains an electron.
To complete its octet.
To achieve a noble gas configuration.
And become
stable. Now it combines with almost all the elements either by losing an electron or by accepting an electron. Okay.
Now we see some important reactions of hydrogen.
Yeah, based on these chemical properties, we will see some important reactions. First one is that hydrogen is neutral, so there will be no change on litmus. Okay.
So the litmus paper test will be neutral, no change in the color.
Yeah. Second one is combustible nature.
Combustible nature of hydrogen.
Okay.
What does it mean, combustible nature?
Combustible nature means that it burns very easily.
Okay.
And it burns with a blue flame. Okay. Here is a note that the gas itself is combustible, but it does not support any type of combustion like oxygen.
Yeah, so as we might see that if we drop incense sticks in a cylinder of hydrogen, then they will burn, but it is not the case with hydrogen. Okay.
Low chemical reactivity when in form of H2. This is because hydrogen H2 is an stable compound and it has high bond dissociation energy.
Yes.
Okay,
so H2 in itself will not react. So this has not to be confused with nascent hydrogen.
This can react, but it is we have to give a high activation energy to react it. Fourth one is action with non-metals.
Okay, so reaction with non-metals we see here.
The first one is oxygen. It reacts on high temperature, as we have already discussed that H2 reacts only on high temperatures. Okay, so it reacts with oxygen at high temperature, and other method is we can pass electric charge to produce water vapors.
Okay, so the idea is to basically provide it some sort of activation energy so that it can react. Right.
It also can react with halogens, and its reactivity with halogen depends on their atomic number. We can see that reactivity with halogens is decreasing down the group. Bond which will be formed after, that is HX bond.
Okay.
It won't be that much stable if the size of X is larger. Okay. So less energy will be released and less will be stable.
Okay, so basically HF bond will be more stable than HCl bond, and that in turn will be more stable than HBr.
Yeah. Then this effect can be directly seen as F2 can react even in dark, but Cl2 in sunlight, and for Br2 and I2 we have to provide high temperatures. Okay. Now it can react with nitrogen to produce ammonia. This is the Haber's process, which is used to produce ammonia commercially. Okay. In this,
the conditions are very important. Yeah?
Conditions are very important. We have used iron as a catalyst and the
promoter. MO is the promoter. Okay.
And it is carried out at 673 Kelvin 200 atm pressure. Okay. It also can react with sulfur to produce H2S. It is also high temperature.
Now we see that high temperature is
almost in
all the reactions.
It can produce hydrocarbons when it reacts with carbon. Okay. Now,
and yes, one more thing is very important, that the product is different at different temperature, even if the reactants are same. Now we see the action with metals or the reaction they have with metals.
Hydrogen gas can directly react with metals, but on heating. Okay. When it
can react with any metal, like does it react with inactive?
No, it cannot react with any metal. It can only react with atoms, metals which are above in electrochemical series.
Okay.
Above hydrogen in electrochemical series.
Okay.
we have already seen that sodium etc are above hydrogen in electrochemical series.
Yes.
That's why here sodium is reacting with H2 on heating.
So I think same will happen
Yeah.
for
If-
hydrogen.
If we take any other
Same will happen for potassium also, I think, because it is
yeah,
above
it
that.
is also above the
Okay.
hydrogen. If we take any other element below hydrogen, it won't react.
Okay.
Okay. Now we see some more reactions of hydrogen with some compounds. Okay. First one is CO. CO reacts with hydrogen to give CH3OH, that is methyl alcohol, on room temperature. This is about
273.
273. That is 0 degree.
Okay. So it's little bit below
Little
room
bit before
temperature.
room temperature.
And it is 200 atm, and ZnO.Cr2O3 is the catalyst
This is
used.
used as a catalyst. The second one is with metal oxides. Hydrogen reacts with metal oxide to reduce them.
Okay.
Okay, and itself it is oxidized. Okay, but this is on heating. H2
So
is
heat is important for this
Ah.
reaction to continue.
now it also reacts with some unsaturated hydrocarbons, almost all the unsaturated
Okay.
hydrocarbons, and it will saturate them and will produce saturated
What do you
hydrocarbons.
mean by saturated and unsaturated hydrocarbons?
Saturated hydrocarbons are those which do not have any carbon-carbon multiple bond.
Okay,
Like in
okay.
C2H6, we see that C. There is no carbon-carbon multiple bond. That is, it is
Okay.
saturated. And in unsaturated compound, we have carbon-carbon multiple bond.
Like, can you draw and tell how it is for C2H4?
Yeah, C2H4.
Yes.
It is carbon-carbon triple bond. And it is linear. This angle is 180 degrees.
For C2H2, this is the case. Okay.
Yeah. And there are many compounds which have carbon-carbon multiple bonds, as you know. Okay. And when these compounds will react with H2 will reduce them and itself will be oxidized. Okay. Hydrogenation of vegetable oils.
Okay.
Hydrogen is used to reduce also vegetable oils and will produce solid fats. Okay.
Okay.
These are also called vanaspati ghees, like etc.
Okay. So we see uses of hydrogen.
Now, first one is manufacturing of ammonia. Haber's process. Ammonia is commercially produced by Haber's process using H2. We have already discussed a Haber process as N2 plus 3H2 converting into 2NH3.
Okay.
This is called Haber's process. Okay. Second one, we have discussed that hydrogenation of vegetable oils to produce solid fats.
Yes.
And in manufacture of chemicals like methanols,
Yes.
we need
CO2H2.
a lot of chemical compounds with like alcohol and ethers, and hydrogen will be used to produce them. This is used in rocket fuel and fuel cells also. And in metallurgical process, hydrogen has a major use because in metallurgical process metals are get to reduce.
So metals are basically produced, or the pure form of the metal is found out in the form of oxide, and then those oxides are reduced with the help of hydrogen to the respective metals, right?
Yeah. It is also used in welding. Now we will discuss water and heavy water. Water has a chemical formula as H2O and its geometry is tetrahedral.
We can see in the diagram there are two lone pairs and two bonds, one with H, one with another H, which gives us the sp3 hybridization.
sp3. In sp3 hybridization, these four are sp3 hybridized orbitals, in which two are used to make sigma bonds and two are used to have lone pairs. Okay, and in sp3 hybridized orbitals we should have the bond angle as 109.5 degrees. Okay, but in this compound this angle is only 104.5 degrees.
Okay, why is that so?
This is because of the repulsion due to lone pair.
Okay.
This lone pair produces a repulsion on this, and this will cause to reduce this angle.
The bond angle is reduced because of the
bond angle is reduced to 104.5 degrees. Oxygen is the central atom which is sp3 hybridized, and 4 sp3 orbitals, and these are
two are used in bonding. We have seen that.
Yeah, other two are in lone pair. Okay, geometry of H2O molecule is tetrahedral, and HOH bond angle is 104.5 degrees. Hydrogen bonding. This is the most important thing about water. The hydrogen bonding is a type of dipole-dipole interaction. This is not dipole-dipole interaction, but a type of dipole-dipole interaction in which we have some partial charge on oxygen.
Okay, and some partial positive charge on
we have some partial charge on oxygen and some partial charge on
and it happens with very strongly electronegative elements, causing that the partial charges would be high and hence the bond is stronger than normal dipole-dipole.
Hydrogen bonding happens only when hydrogen is connected to a very electronegative atom, that is fluorine, oxygen and chlorine.
Okay, only in these cases.
Only in these cases, and that electronegativity difference is very high.
Okay, so here we saw the properties of water, some chemical properties, and then we saw water and what heavy water is. And so now we'll see some more facts about hydrogen.
We were discussing about water, and ice is the crystalline form of water, that is solid state. Ice can exist in 9 different crystalline forms, but atmospheric temperature and pressure it is hexagonal form. Okay, hydrogen bonds are longer than covalent bond, that's why density of crystalline lattice is less than liquid form. Okay. Now this is hard water.
Okay.
What is hard water? This is because of presence of impurities like bicarbonate, sulfates, chlorides of calcium, magnesium ions. Now we have two types of hardness. First one is temporary and second one is permanent. First one is temporary hardness. It is because of soluble bicarbonates of calcium and magnesium. Okay. We can remove this hardness. Actually, temporary hardness and permanent hardness does not mean that temporary can be removed and permanent cannot be removed. These both can be removed, but they have some different meaning. We will see later. And first we will see some method to remove temporary hardness. This is first by boiling on soluble bicarbonates. Okay.
Decomposes into insoluble.
When we boil these bicarbonate, these decompose into insoluble carbonates. These carbonates are insoluble and will precipitate out of the solution. Okay. And in this method we can separate these insoluble compounds and the water will be purified. Not purified, it is actually hardness will be removed. Okay. And second one is Clark's process. In Clark's process, what we do, lime is added to hard water which precipitates out calcium carbonate and magnesium hydroxide which can be filtered out. Okay. And in this, two types of precipitates are produced and these both can be removed and water is filtered. Second one is permanent hardness. Permanent hardness is due to soluble chlorides and sulfates of calcium and magnesium ions. This also can be removed, and first one by washing soda process. Washing soda can remove both temporary and permanent hardness. Okay, when we react Na2CO3 with calcium chloride, CaCO3 that is insoluble and will precipitate out. And NaCl
Cl is soluble, so
also,
it will remain.
yeah, this does not cause any hardness to water.
Okay, this does not add any hardness. Okay.
Yeah. The second one is permuted process or ion exchange process. Hydrogen sodium silicate is permuted, or it is also called zeolite.
Okay.
Zeolite, when it is reacted with metal ion,
Okay.
it produces this Mz2 and sodium ions.
Okay.
Okay, when this permuted is said to be exhausted if all the sodium is
used up.
Okay, we can also remove this permanent hardness by organic exchangers. This is out of our scope, and we can also use Kalgan's process. In this, Na2P6O18 is sodium hexametaphosphate, and it remains as 2Na plus Na4P6O18 2 minus. Okay. When the ions like calcium 2 plus and magnesium 2 plus,
M2 plus may be divalent ions like
yeah,
Ca2 plus or Mg2 plus.
These ions are already present in hard water. Okay, when these reacts with this compound, this complex ion is formed, and this metal ion will be in this complex ion, and this will not be in free form in water.
Okay.
That's why in this way hardness of water is removed. Okay, and this sodium ion will not cause any hardness to water.
So here we saw the various what hard water is and where is the process to remove the hardness from the water. We saw two types of hardnesses: permanent hardness and temporary hardness. So we'll get more about hydrogen in the next lecture.